Thank you all for joining. Thank you all for joining. I'll go through the first three slides, and then we got Doug McIntosh, our special guest, is going to be talking, and that's the most important part of the webinar today. But a few housekeeping tips. We are recording this webinar, and the recording will be made available after we clean it up in a day or so. We'll send it out to all the registrants. We typically reserve the last 10 minutes for questions, but we also would like to keep it pretty interactive. Use your chat window where that red arrow is pointing on the graphic. Use that to type in your questions, and I'll be monitoring it in the background. So if we can answer it by chat, I will. Otherwise, we can answer it at the end as well. So Don, next slide, please. Okay, what's the agenda today? We're going to introduce MecSoft for those of you who are not familiar with MecSoft, and also VisualCAD, which is the product of interest today. And then we're going to be obviously talking about CADCAM implementation at Hancock Central School in Michigan. And then we'll go over an overview of the VisualCAD art and the mill module, how the workflow goes from the art module to the mill, and how they're utilizing it in the Hancock school. And then after that, will actually be a show and tell. It'll be a demo sort of session. Then after that, we will talk about the available educational resources, and then finally questions and answers. So a little bit about MecSoft. MecSoft, for those of you not familiar, we build and market state-of-the-art computer-aided CAM software solutions for CNC manufacturing in a wide variety of industries. A sampling of that is shown in this graphic here: aerospace, automotive, production, music, woodworking, and of course, education is very important to us, and it's also a very large market for us. One of the reasons is we are pretty easy to use, and it's easy to get our handle around a product, and also the pricing is pretty right for the schools. So next slide, please, Don. Okay, a little bit more about MecSoft. We have a lot of customers. We have over 10,000 customers in over 50 countries. We've been in business for over 21 years. Entrepreneurial shops to Fortune 500 companies are our customer, a wide variety of customers, as you can see. But mostly, our bread and butter for customers are mom and pop operations, small operations. Who want to get entrepreneurial shops, things of that nature. And we have loyal, passionate, and repeat customers. People come back, and every year we do upgrade our software, fix bugs, and put in new enhancements based on customer requests, and that's been really popular. And as I said before, we have a very strong educational customer base. I'll touch upon that later after the demo a little bit. A little bit about our products. We have, as you can see, 5 different product lines. All of them are CAD/CAM products, or mostly CAM. We are a CAM-centric company. And what we're going to be seeing today is the VisualCAD is on the left-hand side. It's a standalone product, includes a free CAD module and a simple CAD where you want to do drafting, 2D CAD, and you have a drawing and you want to quickly create that in CAD and then create cutter paths. This is an ideal product for you. And also for education, it's really easy to get a handle around it because of the simplicity. And also, the CAM portion of it is pretty powerful, so you can do really nice things with it, as we were going to be showing later on. And then RhinoCAM, which is again our flagship, which is probably our largest product today. This is a product that's integrated inside Rhinoceros, both 5.0 and 6.0. For those of you who are not familiar with Rhino, Rhino is a NURBS modeler, and it's very popular. And if you haven't, and it's very popular in the educational market as well. So if you haven't taken a look at it, it's worth a look. You have a done 60-day demo, free demo that you can download and play with it. And we have a product called RhinoCAM that's completely integrated in it, and it runs seamlessly integrated inside that product. And that's a good combination as well. And then we have 2 other products, VisualCAM for SolidWorks and LibreCAM. These are targeted at the parametric engineering marketplace, where you have parametric modelers like SolidWorks and Libre Design. And both of these products are fully integrated into these engineering modelers. And they're more commercial oriented, and of course, SolidWorks is very popular in the educational market as well, and so we piggyback on that, and those are good products as well. And then finally, VisualCAM for Onshape. This is our cloud-based offering. We just released it last year, and it's a work in progress. We have the 2.5-axis module right now running on it. We believe that the cloud is the future, and of course, we also believe that it's going to coexist with the desktop. So if anybody's looking for cloud solutions, especially these days with the COVID-19, that's a good solution to look at. And at the bottom of the slide, you see those boxes. Those are really talking about the technologies that we have. Our technology spans from CAD, I mentioned the 2D CAD, as well as simple 3D mesh CAD as well. And then we also have mesh healing tools, mesh decimation tools, pretty nice mesh handling and optimization tools. And then, of course, the CAM proportions include mill all the way from 2.5-axis up to 5-axis continuous machining, turning, 2-axis turning. We've also released a mill turn product. And then we have nesting, parts nesting, both rectangular and true shape nesting. We also introduced a profile nesting module, which is basically toolpath nesting, profile toolpath nesting, which can be pretty useful for laser cutting and machining of that nature. And then art, that's an artistic modeling package. We'll be talking about that a little bit later today. And then finally, also FDM 3D printing technology as well. If you have an FDM printer and you want to drive it using G-code, we have a module that will allow you to do that. So without any further delay, that's a little bit about MecSoft and our products. I'll hand it over to Don and Doug. So go ahead, gentlemen.
Okay, thank you, Joe. I'm very happy and excited to introduce Doug McIntosh. Doug is a volunteer instructor for Hancock Central School in Hancock, Michigan. And Doug has a really interesting background in automotive, and I think everyone will be very interested to hear how Doug got into this and what he's doing now with young people. Doug, are you with us?
Yeah, I am.
Okay.
Yes, I am.
Doug, go ahead and tell us a little bit about yourself and your background and how you got in to helping students.
Okay. Well, I graduated in 1971. That's a while back. Went to work that fall for a Ford Motor Company. They were hiring. The plant was Sheldon Road plant. We made heater cores, air conditioners, and climate control systems for all the Ford models and Lincoln and Mercury. My job at Ford's was I started as an assembler, and then they offered an apprenticeship test, got on the apprenticeship as a tool maker, and we started getting, they started introducing CNC machines. We got a few Bridgeports in, and at the time I was an apprentice. One of the older gentlemen decided that the apprentice should take this, come back and teach everybody. At Ford's, we used a program at the plant called CADCAM, which was probably the easiest one to deal with at the time. We primarily, in the tool room, we programmed a lot of pallets, stuff to hold climate systems that went around as they assembled them. So, typically we'd machine 40 or 50 pallets, put all the holes, and do all the parts that screwed on to the pallets. It was a lot faster than having to do it manually. So that's why we primarily used it. We had done a few molds. We tried one. The problem was, as we got it done, they canceled the car line. It was a 15-ton mold. It weighed 15 tons. And that took about a week to machine that. Lots of programming there. How I got to be an instructor at the high school was, well, I retired from Ford's. Like I said, I was a tool maker. I was also on health and safety at the company. And I used to work 80 hours or more a week. And I worked over 80 hours for 15 straight years. And when I retired, I moved up to the Upper Peninsula. I was in the Detroit area. and moved up to the Upper Peninsula, put a retirement home up, and I just couldn't sit still not doing anything. So I took a job in a machine shop close by here, and one night after work, I walked out of there and commenced to break my back on the ice. So I had to quit that job, and I decided a few months later that all my tooling that was sitting, all my tool room equipment sitting in the garage was just rusting, so I was going to donate it to the high school. I found out the instructor, his name is Gary Michiga. He's been teaching at Hancock High School for 40 years or more, has an open shop night on Wednesdays, 7 to 9 o'clock at night. So I went up there with my toolboxes loaded. I had some friends load the toolboxes in my truck. And when I backed up, he said, "Sir, do I know you?" I says, "No, but you will." And anyways, that's how I got to meet him. Started going up there, playing around on the Bridgeport. And after about a year or so of that, he asked me if I wanted to teach his advanced students. I says, "Well, sure, I can try. I'm not a teacher, but I have taught SurfCam and G-code programming and stuff like that to the other guys at work." So yes, that's what I did. I typically have 4 or 6 students, just 4 or 6. You have to understand that these are high school students. Some of them are juniors, some of them are sophomores. The class is an elective. In other words, he offers 3 different programs to his advanced kids. They could take me for half a school year. They can take auto body repair with another gentleman, much like myself, and they can work with Mr. Michiga. Mr. Michiga keeps them quite busy, so the really advanced kids get with me. So you're seeing one guy on the TV screen. We'll call him Steve. His real name's Todd. I told Don the wrong name. And I have to teach these gentlemen, first off, I have to teach them how to read a micrometer. So that's how advanced they are. They don't even know how to read micrometers. So we teach that. We start on an engine lathe and we do some basic turning. Then we try to get that through real quick, the engine lathes. I get them till they can cut a thread manually. No readouts, manually, just using the dials. And they can do that. And then we go to the Bridgeports. I teach them basic Bridgeport safety. And we'll cut a few things on the Bridgeport, just squaring stuff up, teaching them feeds and speeds. And then we go to the 3-axis mill.
So let me ask you something. How are you fitting in the VisualCAD and the VisualCAM into the curriculum? What are they doing? What are you doing with that?
Well, I teach them G-code programming first. And my philosophy with that is that if they know G-code programming, they can basically run any machine out there if they really learn it.
Right.
So that's why I teach it. And I just basically teach, Steve there is holding a box, and we take scrap wood, glue it together, and we squared up the box with G-code programming. It's just straight moves. That's all it is. You know, they got to teach the Cartesian coordinates to them too. And then we did the inside. Then we put a groove in it and put the lid. I have them do it. Have them enter this manually, the G-code programming. And one of the projects we did was a stamp set, letters of the alphabet and metal stamps. And I made them not only sink the end mill down manually, then move over and then do a circle. I had them do one whole row, 13 letters, manually. Then I introduced the CADCAM software. So I teach them how to draw it up and show them how much easier it is to do in CAM and how much faster it is. That gets their interest. And the reason why I teach the G-code is, yes, I could teach them straight CAD-CAM, but if there's a problem with it, they don't understand what the machine's doing without knowing G-code. So that's why we do it. And then the last thing that Don's going to talk about, he's going to discuss this. We made a mold of the Bulldog. Mr. Michiga requires all the students every year to do a casting project. Now we have a forge, not a forge, but a furnace in the shop. We melt aluminum. They make sand castings in sand. So we made the bulldog plaque that you guys will see, so we could press that into the sand to get the pattern and make it. He requires them to do that, and most of the students don't like working in the casting aspect of it. But Mr. Michiga insists that they do a casting, just so they learn what real work is, I guess. With that said, the gentleman you see here, Steve, he took that upon himself, and then he wanted to put the word junk on it. Don't ask me why he decided to spell it that way. That's what he wanted. He wouldn't tell me why, and I said, okay. So you see on the left side there, we're machine engraving it. And when I get the real advanced students like Steve is right there, and they come up with ideas, they get a better grade. They all start with an A-, and I base their grades on not what they learn, what they do, but attending class. My philosophy on that is employers want your people to come to work. They count on you to come to work, and your grade gets reflected by you attending my class. That's basically how I grade. They find it unique. They like it. I keep them we move at a real fast pace. If I ask them, I said, do you understand? And they look at me and they nod their head, yeah. I said, if you don't ask me a question, I'm going to assume that you understand it. So we move really quick. We have a short amount of time. So I teach basically 2 or 3 days a week. So I only have them 3 hours max a week, which ain't much time. And with that, Don will discuss, this is our bulldog that we're making a model out of it so we can make a mold. I'll turn it over to you, Don.
Okay, thanks, Doug. Yeah, as Doug mentioned, the students have to design a sand casted aluminum part. Basically, it's about an 8-inch diameter emblem. And what you see here is the bulldog is actually the mascot of the school. And basically what you're looking at here, I'm going to be going through this in illustrated detail on how this process works from the art module over to the mill module to machining. So basically what you're starting with is a 2D drawing. On the left here you see a 2D drawing of the bulldog, and through the art module you use the drawing to actually create the 3D relief mesh of the bulldog that you see in the center of the emblem. And that mesh is positioned on an 8-inch diameter base with raised lettering. All this is done using VisualCAD commands. And let's take a look at VisualCAD and how the drawing is actually created. I don't show the drawing, but I show the bulldog. What you can do is set that set the image file as a background image in VisualCAD, and you load the image in on the XY plane, and we're looking at the top view, looking down on the XY plane. The image is set as a background. Then you can use this to actually draw your geometry that you're going to use to create the bulldog mesh. So after you create the geometry, then you go into the art module, and what you see here is the VisualCAD art module. You see the art browser over here on the left. And basically what you're doing is you're taking the 2D drawing of the bulldog, and visual art is raising it upward in Z, like puffing it up, and it's actually called a puff volume operation command in Visual Art. So as you can see here, you got, if you look on the right side, you look down in the top view of the Bulldog, you'll see we got some detail curves that are highlighted. So you have all these detail curves that are created inside the perimeter of the Bulldog, and the puffing algorithm takes those curves and actually puffs up volume between those curves. And in the bottom view here, you see an elevation view of the actual raised puff volume that the ART module creates. So after, this is the only thing you need to do in the ART module is take your 2D drawing, apply a puffing operation to it to get a raised 3D mesh. And that mesh then lies on the XY plane, and you can use it to create your machining operations. In this slide, we're looking at the milling module, and we're looking at a cut material simulation of the plaque. So what you see here is the machining job over here on the left. We're using 2 3-axis roughing operations initially, and then the remainder are 2.5-axis profiling, pocketing, chamfering, things of that nature. So again, up here in the right corner, you see the Bulldog mascot, and then the resulting cut material simulation of the CAM operations in the main screen. You'll see how that is converted from a basic bitmap file to a 3-dimensional mesh object. And here we just show another more of an elevation view of the plaque, where we see the raised Bulldog in the center. We got pocketing going on around that. We got chamfering, things of that nature. So this is the part that is going to be machined. A positive is machined first in cherry wood, as Doug mentioned. That is a proof of concept part. After that, they will machine it in aluminum, and that as a core, a positive core, will be machined in aluminum, and then that core will then be used to press the cavity in the treated sand casting material. Now, there also is another project. There's a number of projects that the students can choose for the Foundry sand casting part of the curriculum. These 2 that we're showing here is just 2 of many that the students can choose from. And in this one, obviously you can see the Nashville Predators emblem there on the left, and also the raised emblem that was created using the ART module. And I guess, as you mentioned to me in another conversation, Doug, hockey is a big sport up there, and I guess the Nashville Predators is one of the nearest hockey teams that the students like. So this is another emblem project that they can choose from.
Well, the Nashville Predators are 1,500 miles away. The Detroit Red Wings would be our state. But anyways, it came about by a student that asked me if I could engrave this, because he was originally from Nashville.
Oh, okay.
And that's how it started. And I said, well, we'll do a casting on it. So that's how it all became about. And yes, hockey is a major sport up here.
Mm-hmm. Yeah, for our international listeners, you can talk about the hockey teams. It's the National Hockey League teams that we're talking about here. So these are ice hockey teams.
Yep.
Yeah.
And what we see here again is the emblem puffed. I'm going to say puffed up into a 3D volume from the 2D drawing, and we're looking at the ART module again here. And it's very simple operation. It's just one command, one dialog. You select the curves and give it some smoothing options and various parameters, and it creates this beautiful 3D volume out of the 2D drawing. And then the art module actually turns that volume into a 3D mesh, then places that on the XY plane, and that's actually what you're machining in the mill module. And here's a look of the cut material simulation of the Predator's plaque. And you can see the machining job tree on the left. We got a number of 3-axis roughing and parallel finishing operations, and also a number of 2-axis pocketing, profiling, facing, chamfering, etc. And I'm going to show you these parts in the actual VisualCAD program coming up here in just a second. And here's another elevated view of that emblem. Okay, so at this point, I'm going to bring up VisualCAD, and I'm going to show you these projects in the actual program. Give me just 1 second to get that going here. I hope everyone can see that. What we're looking at here is VisualCAD 2020, and we're looking at the actual 2D drawing that Doug made from the background image that I showed you earlier. So right now we're looking at the, go ahead, Joe.
Yeah, Don, I think it's worth talking about how Doug made this because it is a pretty intricate drawing, and then maybe Doug can explain how he did this in VisualCAD.
Yeah, as I showed you previously in another slide where we showed VisualCAD with the emblem image loaded as a background. Doug, you want to talk a little bit about that?
Sure. The way I did this was, well, first of all, there was the colored version of that you see. I took a picture of that. It was on the door leaving the shop. Took a picture of that, and I was watching on the website some of the art stuff. So what I did was I put it into a photo program and made a black and white out of it, which makes a bunch of jagged lines. And then I put it into VisualCAD here. And then I went and started cleaning up all the jagged edges. And then I learned, it was also a way for me to learn VisualCAD also. It helped me learn all the commands. And then I started drawing the circles and stuff. And anyways, that's how I got it. And that's what I ended up with right there.
And I wanted to mention here is that up here on the modeling aids tab, there's a whole section here for background images. And basically that allows you to place a background image on the XY plane or any of the orthographic views. And with that background image displayed, you can then draw over that to create your drawing file. And again,
yeah, and you can use NURBS curves to create these nice curvy looking curves that you see. And then I also want to mention that we do have a raster to vector converter as part of the art module.
Okay, let's go over there and actually show the art module here real quick.
Yeah. I'm not sure if Doug tried that, but if you haven't, we can work with this and show you how to do that, Doug.
I think I might have played with it. I'm not sure. Don't remember.
Yeah, you got a number of commands up here on the art browser. We got relief operations, and then here's your raster to vector commands here. So you can convert those bitmap raster objects into actual, geometric line drawings that you can use. That's
what I did. I did do that. Yeah.
Okay. So this is, let's take a look, just a close-up look at this here. This is the volume that's actually created from the 2D drawing. You can see the drawing, on the XY plane, on underneath it, and the geometry is actually puffed up and created a 3-dimensional object that you can then machine with milling strategies. Okay, so let's go back over to, once you got the mesh created, and this is all we need to do in the art module. We use it to create the center mesh object for the emblem. So then we go over into the mill module. And as you can see, Doug added some other, geometry like the lettering and, just some concentric circles. These are used to guide the milling process. And I'm going to show you how that's done. So let's go ahead and turn on some of the additional objects that we created. So here you can see the mesh object in the center, but also we have an 8-inch diameter base that was created, and then also lettering that was extruded down on top of that. So from there, basically what we're doing now is we got a 3D part file that we can go ahead and program toolpaths for. And let's just take a quick look at what the toolpaths look like, and then I'll show you the cut material simulation as well. We've got initially, let's turn the toolpaths on. We've got some basic 3-axis horizontal roughing going on. And one of the new features in 2020 is, if you look, I'll show this in the simulation, but if you look down in here, you have a lot of step minimization paths going on here in the areas that show greater stepped areas. And basically what this is doing is it's combining a re-roughing operation and a roughing operation into one operation. So it does the horizontal roughing initially, then it goes back and it re-roughs areas that have excessive stepping going on. And you can see that in the simulation in just a second. And then that's the first roughing operation, and then we got a second one, which does just the lettering between the two concentric circles here, where all the lettering appears. And then also we have the center bulldog is machined using one spiral machine, 3-axis spiral, continuous spiral machining toolpath. So the tool starts in the center, and it is one continuous spiral at an offset distance until it reaches the perimeter end over here. So that makes a really good effect on the raised bulldog area that I'll show you in just a moment. And then after that, we have some basic 2.5-axis profiling for cleaning up the outside, some more profiling for creating a shelf on the outside of the emblem. And we also have some pocketing going on to bring that 3D relief up higher, even appear to be up higher. So we'll be creating a pocket around it. And then we're just doing some chamfer detailing around the edges. Let's take a look at what this actually looks like in the simulation. And so as you can see here, I simulated it currently already, and you can see the raised areas, the nice detailing, the bulldog in the center, and the coloring you can assign to each operation type, so you can actually design this to look just like the emblem, using the emblem colors themselves. So that's what it looks like in the simulation. Let's just take a look, let's turn the toolpath off. So here I wanted to show you the step minimization. So basically, out in this area around here, you've got large cut levels, which is fine because you've got nothing really going on out here. But when you get into the raised area, a large step down will leave some large stepped areas, which might exceed the amount of stock material you might want to cut with that finishing operation taper tool. So what it does, built into the 3-axis roughing, is it minimizes these stair steps by going in and adding additional tool paths in these areas to create lesser step areas. So that's one feature that was added recently in 2020 that's pretty cool. And then also the lettering, the next toolpath operation goes in and clears out all. Actually, it's we use the 3-axis roughing, but it's actually a finishing operation because we're finishing right up to the edge of that lettering, and that's considered a finishing operation for that lettering area. And then what's really neat here is the bulldog in the center. Let's just do a simulation here real quick to show you how this works here. Let's slow this down some. And let's go ahead and run that. So this is the first 3-axis horizontal roughing operation. And you'll see here in a minute where it'll do the step minimization. There we go. It's starting on it. See where it's doing, coming back, and it's doing a re-roughing operation in these areas. So that saves you from having to come in and actually create a secondary operation for re-roughing this part. Just speed this up a little bit and get to the end of that. So there's the first roughing, and then we're going to do the second roughing for the lettering itself. Let's go ahead and play that. So it's going through and creating horizontal roughing and levels around the lettering area. And also I wanted to mention here that if anybody has any questions about this part file, or for Doug regards to his students and what he's doing there at Hancock Central School, just type your questions in the chat window and we'll get to them in just a second. So basically let's go ahead and finish this out. And let's go ahead and turn the grid off so you can see this a little bit better. And then of course we got the bulldog spiral, which is a spiral toolpath, starts in the center, one continuous spiral till it gets out to the perimeter. And then we have some additional profiling going on, and then we have the pocketing going on in the center, which works it down, and then we have some chamfering detailing going on to cut some of those rough edges off. And also I wanted to show you the other Predators emblem. Give me just 1 second, let me get that up. And I hope everyone can see that. Doug, can you see that?
Yep, see it fine.
Okay, so here, basically the same concept. We started in the art module, and let's go ahead and hide these objects here. This is our actual mesh of the Predator emblem. Let's hide that. And basically, you create your art project, and then you create a puffing operation which puffs that center volume out and places it on the XY plane. And here's a picture of the mesh itself. And again, I wanted to reiterate, the process of creating this raised volume is very, very easy to do. In the art module, you just have one command. You just select your border curves and your interior detail curves, set a few parameters for puffing height, resolution, and it creates this mesh for you. So that's all you need to do. And then you go right into the mill module. So let's take a look at the mill module for this part. And let's go ahead and get this in a good area. We can see that. So here is basically an 8-inch, similar to the Bulldog, it's an 8-inch diameter plaque with a raised mesh in the middle, raised lettering, top and bottom, and some curves that are used for containment around the edges. So let's just review this real quick. I won't simulate it all, but I'll just show you. Here's the horizontal roughing. Again, the step minimization going on here. This one is not raised as high, so there's not as much step minimization required, but it does add it. And you can in the 3-axis roughing operation, you can tell it, what percentage, the step percentage that you want to use for the step minimization when it calculates the toolpath. And then we also, similar to the Bulldog, we got horizontal roughing going on for the lettering. And then on this one, instead of the spiral, 3-axis spiral path, we're using a parallel finishing path, which is a linear motion path going, it's set at 0 degrees. So it's going across the X direction back and forth on the part, creating that 3-axis parallel finishing tool path. And then we have another one just to add some additional detail around the perimeter of the part. And also, similar to the Bulldog, we got some pocketing going on, profiling, etc., and some chamfering. Let's show you what that simulation looks like. Again, this is about a 1/2-inch thick material, and we got the Predator the Predator emblem raised up in the center, really nice with some nice texturing going on there in the raised letters. So let's go ahead and get back to the slideshow. Give me just 1 second.
Don,
yes.
Just before you go off,
okay.
One thing I just wanted to comment on is, as we saw 2 emblems being machined, and we pretty much see basically the very similar operations that we used for machining both of these emblems. So if you have a classroom where kids are doing multiple emblems, you can actually save these operations off in what we call a knowledge base, and then just hand it to a kid, and they can just load the knowledge base, just change the geometry for selection,
yep.
and machine it. So that's a nice automation feature. Maybe you don't want to do it with the kids. Maybe you want to have them learn it. But if you're in a commercial establishment, that's a real time saver. So I just wanted to mention that.
Yeah, just another thing that I want to add to that, Joe, is on the aspect of the knowledge bases. In the art module, you can also create a library of objects that you create. In other words, you don't have to create these from scratch all the time. You can create a library of emblems, and you can save that into a library in the art module that you can draw from. Okay, let's go back over into the slideshow. Give me just 1 second to get that going here. And we're going to talk, Joe's going to talk a little bit about the CADCAM resources. And let's get to the website, Joe, because I know that's where you want to get to.
So before we go to that, the best place to get information about what we offer for the educators is in our website. If you go to MacSoft.com, which is our main website, and then you go to Industries on the menu bar, and then you go down to the bottom, which is Education. You click on that, that'll get you to our education portal. Since we don't have much time actually here, I'm going to just rush through this, and I'll just point out some of the highlights of this area, this portal here. You might want to just scroll down to the bottom and look at some of the case studies we've done, or some of the pictures from different customers. And these are actually pictures, not really case studies. But if you're interested in how people are using our product, if you go back up, Don, there's on the left-hand side, there's a menu where you can click on case studies, and you can look at different schools and how they are. We've chosen a few of these, some of the interesting ones, to do actually a case study and some videos on how they're actually being used. So that's a good place to go and find out how our products are being used. Some of the customers, if you're interested in who our customers are, you can go up there. As you can see from this web page, quite a few institutions, a lot of very well-known institutions, both high schools as well as colleges and universities. So you can browse through, and if you have any contacts in any of these institutions, you might want to talk to them and see how they implement our product. A little bit about pricing. We offer our products, actually there's a slide for that, but I'll go through that very quickly here. We offer lab licenses as well as a campus-wide unlimited license product. And the lab licenses can start at 5 licenses for your lab. If you have a small lab, There will be 5 licenses for the kids, and then one teacher license that you can actually take home and put it on your laptop, so you can work at home with that. CAMPUSCAM, that would be a campus-wide license, unlimited license. So people, as long as a student is on the campus network, they can access the product. The product should be running on a server somewhere inside the campus network. So that's a pretty nice feature for large universities who want multiple products and don't have to worry about the number of kids running it. Some of the, if you want to go back to the the slideshow, Don, I think we're running short on time. So yes, let me talk quickly also about the types of licenses we offer. We have network licenses. All our educational licenses are network license, and they start at 5 user level, and you can add 5 users at a time, and they can go up to 100 licenses, if you will. If you're running more than 100 licenses, then we would suggest using the CAMPUSCAM, which is basically the campus-wide solution that will give you unlimited licenses. And then single-user instructor key can be purchased with any of these options for a very small fee. And that, as I mentioned, can be put on your laptop. You can take it home for working on assignments or doing machining on the side as well. So, all right, next slide, Don. We also offer an annual maintenance subscription. We call it the AMS program, and it offers technical support, priority email, phone, and live login. We can actually log into your machines for troubleshooting. We offer that service as part of the AMS subscription. We also offer a CAMJam video tutorials that include over 90 instructional videos that Don is basically the author of. He puts together these, culls these from different webinars and different demonstrations and trainings that we do and put them together that you can look at and learn. And also we do training webinars, kind of like the webinars we're doing. Right now we're doing more of an instructional webinar, rather a demonstration webinar, but we do every month, we do webinars, training webinars for our AMS customers. And then obviously also you are entitled to 1 new version release as long as your maintenance is active. So that's a lot of value in the maintenance that we offer, and that's something we offer to our educational customers as well. So Don, next slide, please. Yeah, so I think we're at the end of the webinar now. We reserve this for questions. If you have any questions, go ahead and type that in at the chat window or the questions window, and we'll get to it.
I got a quick question for Doug. What is your best experience that you can remember teaching these kids? I know a lot of things going on, and you get close to some of these kids. Do you think they're getting a lot out of the CAM part of the program?
I do. It really is helpful with the CAM aspect after they draw it up to do it in CAM. It's so much faster. But like I said, I like to teach it manually first, just to show them how much more efficient CAD-CAM is. That's why I do it that way. Another thing I would like also to say, I forgot to mention it when I was talking, is Mr. Michiga offers, we're sort of unique in Michigan. Our school, which is a small school, if they take all his classes starting in 8th grade drafting and go all the way through the senior year, they walk out of there as a certified welder. Wow. I find that remarkable for a high school. I have had a couple students came back on a Wednesday night on open shop and thank us for teaching them. They realize how much money they can make in the real world, and it's quite refreshing to have somebody come back and say thank you, because my mission is to pass my knowledge on to the younger generation, because I'm not going to live forever. So with that said, pass it back to you, Don.
Okay. Before
Doug,
we end it, go ahead, Joe.
I have another question for Doug. As a product manager, I would like to know your experience with Visual CAD/CAM. What do you think about it? I know you've used SurfCAM before, and if you can talk a little bit about the product itself, that'll be great. Your experiences with the product.
Well, for me, it was I couldn't buy SurfCAM. That's the one I was familiar with my career at Ford's. So I started checking on the internet and looking at various things. One of them was AutoCAD's Fusion 360. I had that on my computer for a while. I absolutely do not like AutoCAD, and Fusion 360 was not going to make it. Somehow I ran across a search with you guys and tried your demo. And I said, wow, this is really, I really like it. And I ended up buying it, and it's what I teach with. I find it a really easy program to learn. It's all straightforward, makes a lot of sense. If you used any kind of CAD/CAM system, this is the one that you want. It's just the easiest. It's friendly. It's not complex to learn. So that's why I went with VisualCAD/CAM. I just like it. What can I tell you? It works for me.
Thanks, Doug.
Yeah.
Go ahead, Joe.
Yeah, I mean, that's something we hear from all of our, pretty much all of our customers, especially the educational customers. I think that's why we're pretty popular in the educational marketplace. But thanks for sharing your views.
You're welcome.
Yeah. I just wanted to add, as far as the ease of use, I think a lot of that is an attest to how much time and effort that we have put in over the years in the user interface of the product. And you will see right off the bat, wow, this makes sense. This works real easy. It just flows real easy. And it's really nice looking as far as an interface. And making you comfortable using a CAM product is half of the battle. If you're not comfortable, you're not going to learn. So, VisualCAD/CAM and all of our CAM interfaces attest to that. Also, I wanted to mention before we leave, we just published a 2-part blog tutorial on the workflow between the ARC module and the MIL module, and it uses the example files that we showed in this webinar. So if you pop over to the MecSoft.com blog and make sure you're in the Learn CAD/CAM section of the blog, you'll see those 2 blog posts. And it goes into a lot more detail and explains the process a lot more. So if you're interested in doing that, I recommend that you do that. Okay, Joe, any more questions coming in?
Just the last slide. If you just want to show the last slide, I want to show the resources. Yeah, so thanks for joining us today and taking time off your busy schedule, and hope everybody is staying safe. And here on the slide, you see our phone numbers where you can call us or email us at support@mecsoft.com if you have any questions, or also you can send to sales@mecsoft.com as well if you have any questions related to pricing or buying the product. MecSoft.com is our website, and you have the educational resources there that you can look at, and as well as the blog, which Don just mentioned. That's a pretty nice resource for pretty much everybody, both the educators as well as commercial people. So thank you very much again, and hope to see you soon.
Okay, thank you, Doug, for joining us today, and I want to thank all of our attendees for taking the time out to sit with us today. And y'all have a wonderful day and stay safe.